Here we have a Nintendo Switch Lite that came in for no power, and the console is not taking a charge. We already disassembled the board, and I was informed that this console was open before. I already see signs of flux on the charging connector. Customer said the console is not taking a charge and it's not powering on. So we want to check and make sure the charging connector is good. And look at this. There's a problem with the battery connector and you cannot see anything. I see a problem with the battery connector here. The middle pin is probably not making a connection with the center pad. And I see flux on the connector, but I do not believe the connector was desoldered, or maybe it was, because look at the soldering on here. There's no solder here. We have solder here. Or maybe whoever worked on it attempted to remove the connector and was not successful. Because those pins, they look factory, the soldering, even though we see flux. But the person looks like he attempted to desolder, start from the back, from here. You see? We see flux here. Or maybe not, who knows? Let's take a look at the USB-C connector. And it's not looking good. Look at the pins. We need to change the connector. That's number one. And then we'll take care of the battery connector. And we'll quickly go over the board. Maybe we can quickly go over the board now and see if there's anything else obvious on the board. The board looks clean. All right, so it looks like it's a connector, charging connector, and battery connector. No problem. I'm going to apply some low melt solder so we can lower the melting temperature of unleaded. That way it's easier to desolder that connector and no need to apply a lot of heat to a point where we're going to damage the board. We want to do this as safely as possible. There are 101 ways to desolder this connector, and the method we're going to use for today is low melt solder. That's what I like to use always because it's safer and it makes the job easier. Fume extractor on so we do not get high on fumes, and maybe we can use the bigger tip, or this one is good. A tiny bit of low melt solder goes a long way. You see, I just put a tiny bit. Low melt solder is sold on our site in a container that looks like this. It comes with 6 sticks, but each stick will last a very long time. And you do not always use low melt solder. I use it when desoldering AGI connectors, charging port connectors, or maybe a component on the board where it's not safe to apply heat on that area. We use low melt solder to desolder that component, assuming the component is not VGA. Right, you see how the solder bubble is getting smaller? It means it's mixing with unleaded. And we're gonna do this side. Now we can apply low melt solder onto those legs on the sides, and we can apply low melt solder onto the front pins, but there are also pins or pads under the connector that we cannot reach. So those will remain unleaded, but still applying low melt will make the job a lot easier. Let's flip the board and we can clean up later. Apply some flux here. So we are able to see this row of pins, but we cannot see the one under the connector. All right, so let's apply heat. We can apply heat from the bottom or top, but since we do not care about this connector and we do not care if it melts or not, I'm just gonna apply heat from the top. Same difference. The connector is out. Okay. Big Boss just got me another Nintendo board that needs an SD connector replacement. Maybe we'll include it in this video. Right here, he just put the board on my bench and he said SD card. I'm assuming the SD connector. We'll see. And we're gonna apply Flux because Flux helps with the flow of solder. Why so much Flux? Why not? It looks like a lot under the microscope, but it's really just a tiny drop. It looks like the charging connector leg is broken inside, so we're gonna have to manually remove it. No problem. Let's desolder the rest of those holes. Very nice. And very nice. Oh, it's nothing. Okay. Holes are clean. And let's clean up. Look at how nicely Amtech Flux cleans. Very easy. A lot of people ask, what's so special about Inventec Amtech Flux? It lasts under heat. It flows nice, shiny joints. It cleans easy, and there's no bad smell to it, like other fluxes. And where do I buy original Inventec Amtech Flux? Not from eBay, not from Amazon, because you will not find original Inventec Amtech Flux sold on eBay, Amazon, AliExpress, or Alibaba. Where do you buy it from? From us. We are a distributor of the Flux. If you want original Inventec Amtech Flux, you buy it from us. Just log into NorthridgeFix. For those of you who do not know that we are a distributor of the Flux, we sell to everyone from businesses to hobbyists or anybody that needs Flux. You buy one syringe, it's not gonna be discounted by much, but if you buy 10, 20 syringes, then you're gonna get a lot of discount. It's amazing how customers from international countries, they pay so much for shipping just to be able to get this original Amtech Flux. And I'm doing this in up and down motion, not sideways. You can break the pads if you do it sideways. Those pads are fragile. So we can tell that solder liquefied. Let's focus the microscope and check on the pins. Make sure everything is solid. Solid, solid. And all the pins are super solid. Very nice. We're gonna flip the board. Finish the soldering from the back. And then we're gonna check on that battery connector. And then we can test. Okay, and we're done. Let's clean up. Very nice. We did an amazing job. Just look at how shiny those joints are. Part of it is good flux. It helps with the flow of solder. It makes the joints nice and round. Right? Better than factory. And you can tell that solder made its way from the back onto the front for a very solid connection. Same from the back, same from here, and same from here. Just look at that. Very nice. Not even a bulldozer can remove this connector from the board now. Now it looks like the battery connector fell off, and it fell off because the customer probably just put it there and it was not making a connection. We're gonna solder another connector, but before we do so, let's apply some flux. And we're gonna pre-apply solder. Right, and the connector just settled in place. Maybe, oh, very nice. It tried to escape to the 9th dimension, but I caught it. Not today. I don't have time for you. Very solid. And let's measure to make sure the connector is soldered properly. Meter in continuity mode. And we're gonna measure from here. Very good, very good, and very good. Done. And some of you may still ask, why is that customer fixing this Nintendo Switch Lite when he can buy a new one for $200? Data. Save data. If the customer bought a new one, he's gonna lose his data. And that's why sometimes you see customers bring in an older phone or older whatever to fix, not for the sake of fixing the device, but for data. So we gave the board a good cleaning, and my fingernail is still blue because the metal front door, it closed. I was trying to lock the door so I do not get interrupted when making a video, and the door just closed on my finger. Big heavy metal door. Painful. But what can you do? That's why we have 10 fingers. I have 9 more. I'll be back. Right, I just gave the board to Big Boss to reassemble. While he's doing the reassembly, let's work on this other Nintendo Switch board that came in for an SD connector replacement. Oh yeah. We have what, 8, 4? We have about 12 missing pins on this connector. We need to replace it. Without wasting too much time, let's do it. And let's put the new connector on. Just like that. And reflow. Clean up, and we're gonna test. Make sure all the pins are solid. And right there. Maybe we can zoom in more. Pins, they are solid. I mean, they look solid to me. We do not have to test them. But let's test anyway. Go to the other side. And just look at those solder joints. Awesome. And look at the flowing of solder on the legs. Amazing. I'm gonna give it to Big Boss to reassemble and test, and I'll be back to finish the video with the Nintendo Switch Lite that we worked on. Right? The board is super clean. And done. Alright, I just got the board back from Big Boss, the Nintendo Switch Lite board, and he said it's taken a charge, but it's charging at 0.47 amps. 15 volts, 0.47 amps, or 12 volts, 0.6 amps. That's not good. That could be CPU related, and I've had this very same issue with this very same model, Nintendo Switch Lite, where I've replaced every chip on the board and the console or the board would still not work. Let's go ahead and quickly measure, go over the M92 chip and BQ. I just want to measure them to see if we have a short in this area. But otherwise, if not, then we're going to call it a no fix. We're going to deem it a no fix. So if we measure the M92 area, no short, no short, and no short. And Big Boss just put this one on my bench also. It's an LG monitor board. I've done one fix like this on YouTube, and every single day we're getting 3-4 of them to fix. Right now the Thunderbolt port is broken off, and the customer included either the original one or a new one. I don't know. Yeah, it looks like the old one. We'll see. We'll see. Those are the monitors that cost about $1,400 from Apple. Apple are using the LG monitors, and they fail like crazy. If we measure those caps at M92, do we have a short? And we do not have a short. If we measure PQ, measure the cap here, no short, no short, and we do not have a short. Okay, so no short. The fact that the console is charging at 15, 0.47, the M92 can cause the console not to go over 0.47 or 0.6 if you're charging at 12 volts. But based on my experience, M92 will not fix the problem. But I'm just going to give this one last attempt and change the M92 chip and hope for the best. If it works, great. If not, then we're going to call it off, deem it a no fix, and we're going to invoice the customer for the repair attempt fee plus return shipping. Repair attempt fee, the one I spoke about a few days ago. That's why we charge a repair attempt fee. Customer mailed this board over to replace the USB-C connector and possibly the battery connector, and that's what we did. We should be charging a full price because we did what the customer asked for. Now we are facing a different issue. What do? We give it back to the customer. Here, take it. It was a no fix, and do not pay us any money? Of course not. The customer will have to pay a repair attempt fee because we spent time working on it. Even if we just diagnose the board, bench fee. Customer will have to pay a bench fee so we can get rid of all the garbage and all the junk that may come into our shop. If we do not charge a repair attempt fee, then anybody out there will send whatever unfixable device they have. They will waste our time and they will lose nothing. So that's the way we eliminate junk, and that's the way we partially get paid for some of the work or some of the time that we spent working on their device. So let's go ahead and replace this M92 chip and we'll see what happens. And by the way, Big Boss told me the other one that we did, the Nintendo Switch SD connector that we changed, is working perfect. And he left. He just left. Big Boss is the type of guy who works like he's living on the beach. He comes in 12 to 5, but during those 5 hours, he does work that maybe 3-4 people cannot do. Very quick. I cannot keep up with him. He put 3-4 things on my bench to work on. He leaves for 5 minutes and then he comes back with 4 other things that he opened, disassembled, and I'm still working on the first or the second board. So it's a race. Let's grab a new M92 chip. And again, you can find those chips on our site. We had a lot of new items that came in last week and they will be posted on our site very soon. Our new site is up and running. Before we redid the site, we got hit with like 15,000 spam bots. 15,000. And all of them working at the same time. You could not access the site or we were getting database errors. Sometimes things like that need to happen in order to take action and improve. We have a new site that's looking better than ever. So the chip is soldered. Let's wait for solder to harden. We're gonna press and hold. And we're gonna push down on the chip so we can squeeze out any excess, like you see happening on the bottom and left. And newbies are screaming, look at what you have done. Look at the mess on the bottom. Don't worry about it. Because just like magic, we can go like that. The magic of Flux. Without Flux, this would not be possible. You see how those two caps bridged and then I was able to remove the bridge, and that's because of Flux. If we did not have Flux applied to the board, then good luck. You're gonna have to remove that bridge with your teeth. Time to test. But before we test, I need to grab the console with the battery. Plug it in, and what readings are we getting? 12 volts at 0.6 amps, just like before. And that's why I said I've worked on this very same problem so many times and no hope for the Nintendo Switch Lite. At least we gave it that one last attempt. I'm gonna put this on Big Boss's bench and we're gonna invoice the customer for the repair attempt, return shipping, and mail it back to him. After he pays, of course. And what happens if the customer does not pay? Not a problem. We'll keep his console and then we can use it for parts. And that's why sometimes we have a lot of stuff, a lot of donors in the shop. Some customers, they tell you to just salvage it. And others, you have others who appreciate your work. They pay you for the repair attempt and they ask you to keep their device for parts. But like I said, people are different. Everybody's different. Not everyone is the same. We spent a good amount of time working on this console. The time that we spent working on this board, I could have done 2-3 other laptops. But we have to be fair. We have to give the customer's device enough time to deem it a no fix. And so that's it. We're gonna end the video right here. I hope you enjoyed it. Let me know what you think. Leave it down in the comments. And we'll do something else in the next video.